Alright, as usual, we are going to highlight some key clues. The first clues that I like to highlight is the fact that the car is accelerated from rest, which means my initial velocity is 0 meter per second, plus the acceleration given as 5.50 meter per second square. Second part that I'm going to highlight is 4.22 seconds, which is the time duration. The final indication is basically what the question is asking. The question is asking about the displacement during the time duration. Now let's illustrate the situation first. So we have a vehicle. At the initial position, I'm going to put initial velocity as 0 meter per second. Then the new position with acceleration, I'm going to put 5.550 meter per second square with the direction forward. Then I would like to indicate the time duration between those two positions with 4.22 seconds. Ultimately, I'm going to put that delta D, which is the displacement during this time, is unknown. We would like to find out how far it went with the direction. Now let's reorganize what we have and what we don't have on one side. Even though there are various kinematic formulas, the one that I'm going to choose is delta D is equal to initial velocity multiplied by time plus 1/2 acceleration and time squared. And since we have initial velocity as 0, we can basically cancel out VI delta T terms altogether. There is no point of keeping something that is multiplied by 0. Then let's rewrite the formula. We found that delta D is equal to 1/2 A delta T squared. That is the only formula that we can utilize at this situation. We are almost done. What we gotta do is substitution. After the substitution, we have delta D that is equal to 1/2 multiplied by 5.50 meter per second square multiplied by 4.22 second, and don't forget to square the time. After the unit analysis, we found that second square cancel out, and that is what it should be because the unit for displacement in this situation should be meter, and that's the only thing we have. Once you put those numbers in a calculator, which means 1/2 multiplied by 5.50 followed by 4.2 twice, you will have 48.9731 meter as an answer. Since the displacement is a vector value, don't forget the direction, which is forward, and significant digit in this question is 3 significant digits, so I should report 49.0 meter with the direction. So in conclusion, the car moved approximately 49.0 meter forward during the 4.22 seconds. See you next time, y'all.